In general, when we talk about data, we mean a quantity that is measured, in this case from the ocean. For example, the temperature at 4.2 meters below the surface is data. Data itself does not constitute information. However, its processing is what provides us with useful information for decision making, reducing uncertainty or performing calculations. In the Argo program, profilers are responsible for collecting data directly from the oceans, which is transmitted via satellite to the ground stations as we saw in Lesson 1. I know this may sound complicated, but no need to worry about it. We will show a quick example. This is how some of the raw Argo data received from the satellites looks like. As you can see, sets in figures give us relevant information, such as the date and time of data collection. However, the rest of the information contained in the data is unreadable in some way, right? This is because the data is coded. It is not the aim of this lesson to get deep into how to decode this data. However, it is necessary to know that once the data is sent by the satellites, it receives comprehensive treatment through several steps in order to carry out a final conversion from the coded data to readable data in physical quantities. For instance, 18.235 degrees for the temperature, 4.2 meters below the surface. In this way, we have a readable dataset organized by variables. However, when we have millions of observations, it is not easy to share the data in this format. So, how can we get this data in a shareable, scalable, archivable, portable, and self-describing way? NetCDF format is the answer. Bear this in mind because we will probably need it for the next lesson. Let's go back and see how, once the data has arrived at the DAC, it is then selected to avoid including anomalous data, due, for instance, to problems in the transmission or sensor malfunction.